and welcome back to my Project Euler series in Python. So we are at problem 6, sum squared difference. The sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared, etc. plus 10 squared is equal to 385. The square of the sum of the first 10 natural numbers is 1 plus 2 plus etc. plus 10, all squared is equal to 55 squared is equal to 3025. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385, and that is 2640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. Okay, that should be pretty easy. For I in range 10 natural numbers, so we're going to need 11. Let's say we've got sum equals 0 and square sum equals 0, so we can sort of do them 2 in 1. So for I in range, so if we add I, 0 is not going to matter, so it doesn't really matter that we start with 0. So if we do sum plus equals I, and then square sum, if we add plus equals I times I, then that should give us the sum of the squares straight out the box. And then we want the difference, so find the difference between the sum of the squares and the square of the sum. So we basically just want to print out the sum of the squares minus the, let's just do this, sum times sum minus square sum. I mean, I'm guessing that's going to work. 2640. Okay, sweet. So I'm guessing that this is going to work. And that's the answer, I'm guessing. So that went pretty well. So let's just recap. So we start with a sum and a square sum. So for I in range 11, which basically means the numbers 0 to 10. And I know it's natural numbers, but 0 doesn't really matter in this point because it's not going to make a difference when we're adding that up. So we sum them up, and this should be our 55. And then we also sum up the squares as we calculate them. And then at the end, we just need to square the sum and then print the difference. So that is how it works, and that is the answer. Just wondering if there's any way we can sort of do this, but I'm pretty happy with that. I mean, I think sum is a key word, so I don't know if we can refactor it to total just to get that off our backs, and then we can just call this the square total for consistency. Okay, and so then you've got the square of the total minus the square total. You know what? Sorry for being pedantic. Total of squares, just because then it's super clear. Okay, so let's just run this, check the refactoring didn't break anything, we're all good. Okay, what's that? 25,164,150. Okay, sorry for that tidy up, but just wanted to make sure it looked okay. And 25,164,150. Yeah, all good. Okay, so that is problem 6. Let me know in the comments if you have any faster way or neater way of solving this. I'm pretty happy with that solution, and I will see you on problem 7.